two really neat corollaries to the isosceles triangle theorem, and I want to share them with you. The first one involves equilateral triangles, and it says that if a triangle is equilateral, then it is equiangular. So that means that if all three sides are congruent, that implies that all three angles are also congruent. And similarly, we can study equiangular triangles, and we have the following result, which states that if a triangle is equiangular, then it's equilateral. That means that if all three angles of a triangle are equal or congruent, they have equal measure, then in fact their lengths are all going to be congruent, the lengths of those sides. So in fact, what we're seeing here, to put these two results together, is equilateral triangles are identical to equiangular triangles. They actually are the exact same thing. They're one, if you're one, then you're the other. If you're the other, then you're the one. Let's take a look at some examples. Here's the first one. We're given this information, and the question is just find x. So let's solve for x. So it's sort of a fun algebra question that appears in geometry. That's sort of neat. Well, what do we know? Well, I see that, in fact, by these markings, all the sides are congruent. That means this is an equilateral triangle, which by the result we just talked about means it's equiangular, which means all the angles are going to be the same. Well, if all the angles are going to be the same, and we know that they add up to 180 degrees, then we know each one has to be 60. 60 plus 60 is 120, plus 60 is 180. So therefore, this angle, which we're told to be 2x plus 10, where that x is just some unknown, that has to be 60. And so if I solve, I see 2x equals 50, and so x equals 25. And here's an example where the only question is just find x, and so I found it. Turns out it's 25. Neat. Let's try another one. Here, the question and challenge for us is to see if we can figure out the value for the unknown t. So we want to solve for t. But by this diagram, we see that these angles apparently are all congruent to one another. Therefore, this is an equiangular triangle, which we know from our previous result is also equilateral, which means that all the sides are congruent. Well, great. If all the sides are congruent, then this length will equal that length, and one of the lengths is given as 2t plus 13, while the other is given as 5t plus 1, and we know they're equal, so I can now solve this equation. If I bring the 2t over here, I see a 3t. If I bring the 1 over to here, subtract it, I see a 12. And so I see t equals 4. So solving, I see t equals 4. See how we can use all these theorems about geometry to actually answer interesting questions about unknowns.